Well, hey there, everybody. It is 2 hours UTC, and it is once again time for Astronomy Daily Live. So this is just a daily gathering of friends together, circle of friends, or the lounge, or the porch. Uh, you know, I'm still trying to remember what Hip called it the other day. It was so great, and I don't remember what that phrase was, but whatever it was really, really neat. It's like a virtual porch, right? We're all coming together, just relaxing. This is a very casual, fun get together of friends to, you know, just sort of forget about everything else and come together and think all things astronomical. Which is actually a lot of thinking. Um, Uh, so yeah, come on in, come on in. Nice to see everybody. I'm gonna check out the chat here really quick. We've got Bobby on the panel again. Bobby, what is happening?
Contraya! Like on Stargate, that little man, he went Contraya!
Did he? All right, cool, very cool. I think I missed that part. Cheers! I've got the coffee here, a little bit of coffee, and I've got the. I went for the dihydrogen monoxide tonight, the H2O, because it's very energetic and very just awesome, right? Um, and I try to limit my exposure to this because it's just so incredibly amazing, right? But it's that kind of a day, so it's like, hey, cheers.
Cheers, and I had to say, hey, the sexy stalker, Miss Lady Catherine, in the porch.
Hey there, Catherine 313. Nice to see you there. Uncle Bill painting the chat yellow, as he does. So hope everybody's doing well. Hope you were able to catch there were a few live streams of the lunar eclipse, and so hope you were able to catch a little bit of that. If not, there's going to be a gajillion pictures, so don't worry about it at all. But it is very, very cool to see it more or less live. That's very, very cool. Actually, actually, one of the most exciting things for me watching it was that the person actually doing the imaging was after a while I figured out he was taking like 2-second exposures and then just running that, so like really, really slow video. And what that allowed us to see is a very, very widely separated binary star being actually what's the word, occulted by the moon. The moon went passed in front of this binary star, so that for me was probably almost as exciting as the eclipse itself, because it's like it's something different, and it was pretty cool to see that. So yeah, hey. So yeah, it was nice eclipse. Now I need to correct what I said yesterday. I was thinking in sort of a backwards way. I had said that because the size of the moon was smaller, that the length of the eclipse was going to be shorter than normal. See, the moon was very, very close to um, apogee. And apogee is the furthest distance from us, which means that it looks smaller than what it normally would anywhere else, right? At perigee, the closest distance it gets to Earth, uh, it looks pretty big, right? Relatively speaking. But apogee, it looks pretty small, pretty small. So that's why on the Discord channel I posted a picture of an eclipse. It's sort of like a cartoon, so it's not to scale or anything. But I just wanted to give you sort of a visualization here of what was happening.
Okay.
So I'll
Now,
put.
about the lunar eclipse, so we're going to be looking at those pictures now, or we're going to do it tomorrow?
Oh well, if you'd like to look at some now, we can certainly do that. Um, I'm sure they're out there. I'm sure it's not going to be too hard to find.
No time like the
So,
present.
okay, well, that's cool. We can certainly do that for sure. So here's here's the setup, right? We've got the sun over here, the Earth in between the sun and the moon, and the Earth, of course, casts a shadow, which the moon moves through, right? The moon is going around the Earth like this, right? And so uh, the eclipse actually occurs because the moon is moving through the Earth's shadow, right? So the beginning of the eclipse, there's sort of two beginnings, right? There's the penumbra, which is this wider thing here, right? And then there's the umbra, which is the actual shadow. And I mean, this is highly exaggerated, but you can kind of see, right, that I mean, it's not straight, right? It's sort of at an angle, and that's because the sun, right? And again, this isn't to scale, so it's not all that great. But the sun, only shines light from here down to the edge of the earth and then over. So you know, you don't get parallel lines here of shadow. You sort of get this kind of funky thing. And the penumbra is just diffraction. It's all it is. It's an optical effect, um, you know, caused by the the edge of the Earth itself, and also the atmosphere of the Earth scatters light, and so you'll get a penumbra and then the umbra itself. And so, you know, at a certain distance from the Earth, the size of the shadow is constant, right? That's not going to change from like here to here, right? So if you kind of imagine the moon, okay, moving along its orbit like this, right? Now at some point, maybe maybe about here, right? The moon is about that size, right? At some point, the edge of the moon is going to hit this first uh, um, dark shadow point here. That is technically the beginning of the main eclipse, and then it's going to move through that shadow, right? Moving at what we can say is a pretty constant speed, right? I mean, it's not, it's changing, but it's very, very, very slight over this distance. And again, this is a highly exaggerated um, image. This is not to scale in any way. I mean, even the size of the Earth and the Moon isn't right, and of course, the size of the Sun isn't right. So nothing about this is to scale. It's just to show you the geometry, right? So as the moon moves through this shadow at more or less a constant speed, it's going to move, of course, all the way across. And then as soon as this edge hits here, it's going to come out of the shadow, right? And then what about here or so? This edge of the moon here or so, this edge of the moon will come out of the shadow. And at that point, the main eclipse is finished. So if the apparent size of the moon is this size, say, it's going to take a certain amount of time for it to cross this shadow path, right? But if the apparent size of the moon is smaller, right, then it's going to take a longer amount of time to move through that shadow, if you assume that the speeds are the same, which they are. So, that's why a moon at apogee will appear smaller and therefore take a longer amount of time to move through Earth's shadow. And so today's eclipse, or yesterday's eclipse, I guess I've got to say, was a pretty long one. I don't recall exactly how long the whole thing was, but I want to say it was at least a couple hours, maybe a few hours. So pretty amazing. And yeah, I was thinking about that sort of backwards yesterday. So yeah, greatest apologies. And yeah, mistakes are going to be made. It's complicated, right? I mean, you've got to be able to sort of use your imagination a little bit, and that imagination has to be flexible, and that's really, really hard. I mean, even with a little bit of help like this, trying to visualize things, it's still complicated. And don't let anybody tell you this is a simple thing at all, because it's not. So yeah, but that it's a pretty exciting event. It does happen a couple times a year, so it's it's not incredibly rare. What makes this a little bit more rare is the fact that it was so long. Hello, Space TV. Nice to see you there.
Welcome,
Get,
welcome.
yeah, I'm getting up early. Getting up early. Okay, yeah, Space TV. I was just actually talking about that. It more or less has to do with the apparent size of the moon, and so if that size is small, then it's going to take longer, and the eclipse is going to last longer. And if the apparent size of the moon is large, then it's going to take a shorter amount of time. And that varies, depending on uh, where the moon is in its orbit when it gets into this kind of a configuration. So yeah, I was just talking about that right before you came on, or just as you came on. So that's a pretty exciting event. That, as I said, lunar eclipses a couple times a year. Usually, 2/3 of the planet can see some of it. This time, those of us in North America did not see it. The moon was on the other side of the planet. So yeah, we missed this one. Yeah, as I said, it happens a couple times a year. So catch the next one. Likelihood, that you'll catch the next one. No worries. No worries. All right, I'm going to stop sharing. Come back over here for now. It's Yes.